Hello everyone, my name is Mirgan Gop. I am final year student of Civil Engineering Department, Faculty of Engineering and Technology, University of Lucknow. I am here to present a seminar on geothermal energy piles. In this, we have table of contents. In this, first we have introduction, construction of geothermal energy piles, how a geothermal system works, test on geothermal energy piles, challenges and limitations, impacts on environment, benefits, case studies, future trend, conclusion. Now introduction. Geothermal piles are heat exchangers pipe consist of pile foundation combined with closed loop ground source heat pump system. These loops are normally a series of high density polyethylene tubular pipes that can transmit a fluid throughout the foundation. Geothermal piles are serve dual purpose. Firstly, they serve a primary objective of transferring load from the structure. Subsequently, they serve secondary purpose in extracting geothermal heat from the ground for heating or cooling to the supported structure like building. In this figure, we have many geothermal piles which are going too deep into the earth. In this, blue indicates the cold water coming from the building and red indicates the hot water going into the building. Now, construction of geothermal energy piles. In the construction of geothermal energy piles, the pile diameter and length should be designed to resist the applied structural loads. Several closed-ended loops of high-density polyethylene pipes, generally 25 mm diameter and 2 to 3 mm wall thickness, are fixed evenly around the inside of reinforcement cage for the full depth. The soil is bored out of the ground and a rigid welded reinforcement cage is inserted. Loops are fitted with heat transfer fluid. These fluid are water with antifreeze or saline solution and fitted with locking valve and manometer at the top of pile cage. Before concreting, the absorber pipes are pressurized to prevent collapse due to the fluid concrete, and this pressure is maintained until the concrete hardens. A pipe is placed to the base of the pile and concrete is poured through the pipe and it is raised up as the concrete fills the pile. Once the pile is finished, the absorber pipes are connected to a heat exchanger, then connected to a secondary circuit of pipes in the floors and walls of building. These are the figures of reinforcement cage and geothermal piles. Now, how a geothermal system works. In these systems, the heat transfer fluid are moving throughout the primary circuits like pile foundations or heat exchanger piles and secondary circuits like upper buildings or supported structures with the help of heat pump. Working of geothermal piles in winter and summers. In winter, the atmospheric temperature is lower than the temperature inside the earth, so the cold fluid is coming from the secondary circuits like supported structures or buildings, and hot fluid is going inside the secondary circuits. In summer operation, the atmospheric temperature is higher than the temperature inside the earth, so the hot fluid is coming from the secondary circuits and cold fluid is going inside the secondary circuits. Now tests on geothermal energy piles. The first one is pile static load testing. It is done for measure pile load capacity. It gives settlement load graph. Now the figure is reaction beam method of pile static load testings. In the we have anchor piles and test piles. The hydraulic jack are pushed against the test beams and by the action to reaction method. The test pile is going to settlement. Now the second one is pile dynamic load testings. It is done for measure load carrying capacity of pile by applying a dynamic load on pile. Now, the third one is thermal response test. It is an on-site test used to determine the thermal conductivity or thermal resistivity of soil surrounding a ground heat exchangers. Now, challenges and limitations. A significant cost associated with any deep geothermal borehole is the drilling required for installation. Piles are only installed at site where pile foundations are already required. During a heat exchange operation, the pile will expand and contract relative to the soil as heat is injected and extracted. It can have a significant effect on soil strength. Areas with rock or high groundwater may not be suitable because of rock have less conductivity and in high groundwater installation issues is occurs. Now impacts on environment. Reduce carbon footprint. Geothermal piles significantly reduce carbon emission by utilizing the Earth's natural heat for heating and cooling purposes. Renewable energy source. Geothermal piles harness the Earth's renewable energy, making them an eco-friendly alternative to conventional heating and cooling methods. Now, benefits. Reducing energy cost. Geothermal piles provide a cost-effective solution for heating and cooling and resulting in significant energy savings. Environmental sustainability. By utilizing the Earth naturally, it reduces greenhouse gas emission and help combat climate change. Long-term durability. Geothermal piles are designed to withstand extreme weather conditions and have a longer lifespan compared to traditional foundation system. Now, the case studies. First one is the Crystal Docklands, London, UK. The Simons is the design and opening company of this structure. This is the permanent exhibition on sustainability. Most sustainable buildings in London. Vertical closed loop geothermal energy piles. It has 614 kilowatt cooling capacity and 614 kilowatt heating capacity and completed in 2012. The second one is Neo Bankside, London, UK. This is completed by Rogers Street Harbour Plus Partners. This is three apartment towers in these vertical closed loops. In these 130 piles, 130 piles at 52-meter deeps, 650 kilowatt cooling capacities and 760 kilowatt heating capacities, 7 heat pumps of 130 kilowatt capacity each. It is completed in 2011. Now, future trend. Technological advancement. Advances in drilling and construction technologies could improve the efficiency of geothermal foundation piles. Increased utilization. As concerns about climate change grow, there may be an increased focus on sustainable and renewable energy sources. Integration with smart building systems. This could include automated control systems that optimize energy usage based on real-time data, weather conditions, and building occupancy. Improved heat exchange systems. Enhancement in the design of heat exchange system could lead to more efficient transfer of geothermal energy from the ground. Research and development. Continued research and development in the field of geothermal energy will likely contribute to the improvement of foundation pipe technology. Now, conclusion. Geothermal foundation piles represent a forward-looking and sustainable approach to construction, offering both environmental and economic benefits. As technology continues to advance and awareness of environmental issues grows, geothermal solutions are likely to play an increasingly important role in the construction industry. Thank you.